Hello everyone, welcome to this TwinCAT 3 PID series video. In this video, I will introduce step 2. How can we set up the TwinCAT 3 project from the scratch, and how can we configure the hardware configuration as well as this cyclic task. In the previous video, I introduced how can we download the TwinCAT 3 software and this TF4100 controller toolbox. Also, I introduced how can we download the PID sample program. In this video, I will set up a new TwinCAT 3 project and we start from the scratch. If you are going to learn how to implement the PID control inside this TwinCAT 3, so you can follow me step by step. And you will learn how can we set up a new project from the beginning. Okay, let's go to the TwinCAT 3 software. In the previous video, I introduced how can we open this PID control loop sample program by using the TwinCAT 3 software. And in this video, we will firstly set up a new project. Okay, so I will set up my new project under this directory, that is a Beckhoff PID. And let's right-click TwinCAT XAE, run as an administrator. And to set up a new project, let's click File, New, Project. Firstly, double-check the location. So let's select the folder directory. I will set up this project under this directory, Beckhoff PID. Select the folder. And from here, let's set up the project name. We can call that TwinCAT 3 PID project. Make sure you are selecting this TwinCAT projects, TwinCAT XAE. And we will set up one project under this directory. All the projects will under this directory. Okay, so this project is named the TwinCAT 3 PID project. It's here. This is one shelf. The core things that is this PLC project. So from here, we will right-click, add a new item. We will set up one PLC project under this solution project. Okay. Select Standard PLC Project. Double check the directory. By default, it should direct to this solution project. Okay, our folder directory that is TwinCAT 3 PID project. Okay, so here we will name, this is a PLC project name. We will name PLC PID. Click Add. Select this standard PLC project and click Add. Okay, so this is the actual PLC project here. So once we set up this PLC project, you will find under this folder, we set up one folder named PLC PID. All the PLC information are under here. Okay. The main program of this PLC project, that is this, under the POU, that is this main, that is a main program. To implement the PID control, we need to add a library that is a control toolbox library. So under this references, and here click Add a library. So we will type in the controller toolbox and let it search. So let's scroll down and find out. We need to select this TC2 Controller Toolbox. That is a library to implement the PID controller. Select OK. After a couple seconds, it will add this TC2 Controller Toolbox. So under this toolbox, we will have a quick review. So all the controller library are under this controller toolbox. They are here. Okay, so this is the added references. And as we know, to implement the PID controller, we need to use the cyclic task to call the PID. So most of the time, we will use 100 milliseconds as a base. From my experience, I would like to use 100 milliseconds as a basic cyclic time to call this PID controller. And the actual sample time of the PID controller, we can also set a value inside the PID controller. For example, we can set 1 second or 500 milliseconds as a cycle time of the PID control. But firstly, we need one cyclic task to run a program, and this program will call the cyclic call this PID function block. By default, there's one cyclic task that named the PLC task. So this PLC task calls this main. That's why this main will be coded by this controller. But what's the setting of this PLC task? We can find out the information under the system. And under the task, we will see by default, this TwinCAT 3 project, we will set up one PLC task. By default, it will set cyclic ticks, that is 10 milliseconds. That means every 10 milliseconds, the system will call this main. And this regular main will call other programs. In the actual project, a regular operation or programming method, we will be using this main program to call other regular program and use another cyclic task to do the cyclic call the PID controller, the PID function block. Basically, this cyclic task will be 100 milliseconds or 200 milliseconds cyclic time. That is different with a regular main task. So from here, we will set up a new task, add a new item. So we can call this task cyclic task. We will name that 100 milliseconds. And this is TwinCAT 3 task. Select OK. And double click. So here we will set 100 milliseconds. That means once this controller starts to run, the period time of this task, that is 100 milliseconds. Every 100 milliseconds, the controller will call this task. Okay. And till this step, let's build this project first. Okay, so far there's no any error after the build. Okay. So from this POU, we will set up another program. This main program is called by this PLC task, and this PLC task is running as 10 milliseconds. And to call the PID controller, we will set up one specific program. That specific program will be called by this cyclic task that will run 100 milliseconds cyclic time. So from here, let's set up a new program. We will name it PRG_PID call. The language we will program as a structural test. Okay, click open. And this program will be used to call the analog input scale and analog output unscale, as well as a PID function block call. And the sample time of the PID, we can also set the 1 second or 500 milliseconds inside the PID. And how can we link this PID call, this program coded by this cyclic task? So from this project here, let's right click, click add. We need to add this cyclic task under here. Select this reference task and click this cyclic task 100 milliseconds and click the open. So we will see we import this cyclic task from this system to our PLC project. And from here, let's click add the existing item. So we will add this PRG_PID_ call, this program, under this cyclic task. See? So through this way, we will link this program with this cyclic task. You can understand like this way. This cyclic task will be organized by the hardware, and this is our program. So through this way, we connect this program software with the hardware setting. Okay, once system start to run, This program will run every 100 milliseconds. So till here, we set up one fundamental things. Once we copy the PID function block from the sample project, we can use this program to call the PID function blocks. Okay, we will leave this temporarily here. And in actual case, other than this software area, we also need to build up the hardware configuration, right? We need to set up the signal modules, for example, digital input, digital outputs, analog inputs, analog outputs. So to configure and set up the hardware configuration, we need to go to the I/O here. Under this device, we can scan or manually add all the hardware configuration. If you are connecting one actual Beckhoff controller, that controller has a signal input, signal outputs. So firstly, you need to connect this actual hardware. To connect this actual hardware, I used a couple videos to introduce how can we connect the actual hardware before. So I will paste the link under this video. If you already connect this hardware system, you can right-click this device and click this scan. The software can upload all the online hardware configuration. In this video, I will manually add the hardware configuration, add the digital inputs, outputs, and analog inputs, outputs. To manually add everything, we can click this add a new item. The main field bus of the Beckhoff system, that is a EtherCAT system. So most of case, we will select this EtherCAT master. Select. And under this EtherCAT master, we will select one interface module first. So most of case, we will select this power supply first. That power supply can supply 2 ampere to the E bus. So this module, that's the EK1200. This is the mainstream configuration. Okay. So under this EK1200, we can add modules you like. For example, let's add 4 different modules here. I will add a new item. So firstly, let's add digital inputs. From this hardware list, we will see all the catalog of the hardware modules. Okay, let's go to the digital inputs terminals. That's the EL1000 series. And I will select this EL1008. That is the EL1008. That is the typical 8 channels inputs. Select. Okay, let's select the next. Let's select the digital output. That's the EL2000 series. And let's select this EL2008. That is the 8 channel standard digital output. Okay, and then next, let's select one typical analog input. For example, I will select this EL3044. That is a 4-channel analog input, 0 to 20 milliamp. Okay, and next, let's select one analog output. Analog output, select here, and the typical output, for example, this 4024. That is a 4-channel analog output, 4 to 20 milliamp. Or you can select this 4014. That is a 0 to 20 milliamp. Okay, I will select this. Okay, these are 4 typical modules. They are signal modules. Other than that, we can also select one interface module. So the interface module, that is a system terminals, that is a 2-port EtherCAT junction. This allows this system can communicate with other EtherCAT remote stations or modules. Select OK. So this is just a basic demonstration how can we configure the hardware of the TwinCAT I/O systems. And you will see there's no CPU configuration at here. That's because from the Beckhoff style, that controller, that is a one system, that is a WinCE or Windows system, and that is a one PC system. And the configuration of the controller, that is at the top of this project tree. Okay, till here, let's compile the project and see if there's an error here. It shows device EtherCAT need a synchronous master. The reason why it shows this error, that's because we configured all the I/O here, but till here we haven't connected any I/O links to this hardware configuration. So it pop up this. We will temporarily skip this, ignore this. Okay, so other than that, there's no other errors. That means currently all the settings are correct. So till this step, we set up this empty project. We prepare this program. This program will specially use to call the analog input, analog output program, as well as the PID controller. In next two videos, I will show how can we scale the analog inputs and unscale the analog outputs. They are very common used in the practical projects. So the analog input data will be used as a process value input to the PID. The analog output value will be connected to the PID output control. This will be used to build up the whole control loop. Alright, that is this video. See you in next two videos. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.